Our work is a surface plasmon resonance sensor based on a D-shaped photonic crystal fiber with a bimetallic layer. Well, here we present the design structure of our dispositive. It's obtained by side depletion a PCF with an hexagonal array of air holes on a matrix of used silica. The diameter of the fiber is equals to 24 micrometers, and the relation between the diameter of the air holes and the distance of two adjacent air holes is equals to 0.88, while the pitch or the distance between two adjacent air holes is kept fixed with 2 micrometers. The gray slab in the flat surface of the dispositive is the silver and the yellow is the gold. They have the height of 40 nanometers and the width of 5 micrometers. To evaluate the sensing properties of the dispositive, you use a finite element method using the software console. It's also used a perfect meshed layer with 10% of the diameter for the truncation of the computational domain. Well, here in the figure 2, we have the absorptions of Y and X polarizations and the real part of the surface on plasmon mode. And also we have the effective index mode for the Y polarization. In two different wavelengths, the SPP mode intersects the fundamental core guided mode, increasing the core mode loss due to the coupling between the fiber core mode and the surface on plasma mode. At this point, we have the maximum losses for the silver and gold resonance respectively. The absorption peaks shift along the wavelength when the refractive index of the analyte changes. Therefore, the analyte can be measured by the position of the wavelength peak. To confirm the sensing properties, we measure the losses of the sensor. The configuration presents two fundamental modes, Y and X polarization, but only the Y polarization mode is considered to investigate the propagation loss, because the X polarization does not present a remarkable resonance peak. Here in the figure 3, we present the shift of the resonance peak in loss spectra under different analyte refractive index, starting by 1.26 to 1.33. Here in figure 4, we also present these absorption curves, starting by 1.34 to 1.37. So the location of the resonance peak is directly proportional to device sensitivity. And the table 1 here presents the sensitivity and resolution for the variation of analyte refractive index. A better result is obtained for a refractive index around 1.36 over here. Well, as conclusion, we report a refractive index SPR sensor based on a D-shaped photonic crystal fiber with a bimetallic layer. But the dispositive has two independent resonance peaks, which has potential interest for multi-parameter sensing. The first parameter, refractive index, shows a preliminary results. The sensitivity is around 3010 nanometers per refractive index unit and a resolution of 3.32 10 raised minus 5 refractive index unit. And finally here my acknowledgements to the Portuguese and Brazilian teams who helped me to carry out this work. Thanks.